A building's climate is important to its occupants because humans have a narrow range of temperatures in which they can comfortably work. Proper ventilation provides fresh air and can reduce sickness by removing bacteria. Climate control concerns itself with the heating, ventilation, and air conditioning system of the home and workplace. A heating, ventilation, and air conditioning system is known as HVAC for short. Its installation and operation is accomplished by HVAC technicians, HVAC mechanics, sheet metal workers, and insulation workers. The installation of HVAC systems will vary by the size of the construction job. In small home building, it may be completed by 1 or 2 people. Often these people have additional skills in plumbing and electrical installation. House ductwork will usually be purchased ready-made, as will the furnace and the central air conditioning unit. On a large installation, ductwork might be done by sheet metal workers, electrical work by electricians, and installation of piping, condensers, and other components by plumbers and pipe fitters. Heating, ventilation, and air conditioning involves many appliances. Generally, these appliances are installed and serviced by HVAC mechanics with varying degrees of specialization. In some industrial and commercial construction, a mechanic need only be experienced with installing and servicing the equipment of one manufacturer. This is because a large building may have heating and cooling units built specifically for it. HVAC mechanics must have a high school diploma with classes in math, mechanical drawing, machine shop, electricity, and physics. HVAC mechanics usually train on the job for 4 years following high school. The size of the structure will define the type of climate control, size of equipment, and choice of fuel necessary to maintain comfort level. Hot water heat, sometimes called hydronics, can be fueled by oil, gas, or electricity. This system uses a central boiler and pumps heated water to baseboard radiators. This will require pipes and baseboard units installed by a heating plumber. In hot air systems, the air is heated in the chamber of a central furnace. When it is warm enough, a sensor turns on a fan, forcing warm air through a series of ducts. After warming the room, the now cool air travels through return air ducts to the furnace where it is filtered, heated, and recirculated. This type of system is self-contained and reuses the air within the structure. It can also be the most economical for a family residence because the same ductwork can be used for both heating and air conditioning when central air is connected to the system. Most new structures include central air conditioning, but older homes and buildings may use a window or wall air conditioning unit. 2 types of electrical systems can be installed. The first involves blowing air across a coil of caloric rod. A caloric rod works like the heating element in an electric stove. This system is similar in function to the self-contained forced air heating system. There is a central heating unit and ducting for distribution of the heated air. The second system involves installing baseboards with a caloric rod inside, just like the hot water system. The advantage of this second system is that the temperature in each room can be adjusted individually. Because the cost of heating with electricity is higher per cubic foot of room space, any electric heating system will be expensive to operate.
When the house starts being built, we go in what we call rough-in. And as it being built, we put in the heating ducts in the whole house, the ventilation for the stove, the laundry vents, dryer, bathroom vents, and then set the furnaces, set the air conditioning, run the line sets, set the registers, and the house is done.
Solar is becoming a popular method of heating. This is because the technology surrounding solar heating is improving, and the cost of other fuels is increasing. Basically, there are 2 kinds of solar heating systems. The first is called passive solar heat. Passive solar houses are designed so that a large bank of windows face the south, where the greatest amount of sunlight comes for the longest part of the day. The sunlight passes through the windows and strikes a heat sink. A heat sink can be any dense material that will collect the heat generated by the sun. Oftentimes it is a concrete floor that can be several feet thick and insulated underneath, or a concrete or block wall. The heat sink collects heat during the day and releases it gradually over several hours during the evening. The second system is called active solar heating. This involves pumping a liquid or blowing air through a system of glazed panels which face south. As the liquid or air is heated by the sun, it is circulated through a central heat storage reservoir. Because of the reservoir's large amount of heat-absorbing capability, the sun's energy is available whenever heat is needed to warm the structure. The heat energy is transferred throughout the building by methods similar to standard forced air furnaces. A few years ago, solar heating was not considered an effective method of heating in climates that did not have a great deal of sunny days. In fact, buildings in most northern climates may not be able to rely exclusively on solar heating. As the price of fossil fuels climbs and houses become better insulated, the cost of installing a solar heating system may become more attractive. Another method of heat, which is difficult to rely on exclusively, is wood. Fireplaces are usually so inefficient that they need to be considered as ornaments. However, wood-burning stoves are extremely efficient and produce a tremendous amount of heat. Wood-burning furnaces can be installed to act as an auxiliary to a conventional furnace. The problems with burning wood as a primary heat source are that the homeowners must have a steady supply of inexpensive firewood, and someone must be at the home throughout the day to feed the stove. In forced air systems, heating vents are more efficient near the floor, and air conditioning vents are more efficient near the ceiling because hot air rises and cool air descends. However, many houses built today will combine heating and cooling vents by locating the vents which channel the air into the room on the ceiling and the return air vents near the floor. Most ductwork is designed to fit between studs in the wall and the joists, although some commercial buildings may expose the ductwork and treat it as part of the decor. Residential ductwork is available off the shelf, while the ducts for large commercial buildings are usually custom-made. Both types are installed by sheet metal workers. Sheet metal workers usually fabricate commercial building ductwork at a shop away from the construction site. Working from blueprints or instructions from supervisors, sheet metal workers measure, cut, bend, shape, and fasten pieces of sheet metal to make ductwork and other custom products. In shops without computerized equipment, and for products that cannot be made on such equipment, sheet metal workers use hand calculators to do the required mathematics and use tapes, rulers, and other measuring devices when performing layout work. They cut or stamp the parts with machine tools. Large sheet metal machinery can form and connect ventilation ducts for even the largest of commercial or industrial buildings. Ducts, pipes, and tubes are installed by joining them end to end and hanging them to metal hangers secured to a ceiling or a wall. To hold pieces together, workers may bolt, weld, rivet, solder, or use specially formed sheet metal drive clips or other connecting devices. It is recommended that sheet metal workers have a high school diploma. Courses of study should include math, science, drafting, and blueprint reading. Sheet metal workers serve a 4-year apprenticeship. Properly insulated buildings reduce energy consumption by keeping heat in during the winter and out in the summer. Installing insulating material is the responsibility of insulation workers. Insulation is usually installed around pipes, water heaters, walls, and ceilings. Heating and cooling ducts can be wrapped in fiberglass or other insulating material. This material can be cut to size and secured with tape or glue. When covering a pipe, insulation workers measure and cut a tube of insulation to the proper length, stretch it open along a cut that runs the length of the tube, and slip it over the pipe. This may be covered by wire bands, tape, tar paper, cloth, or canvas. Sometimes sheet metal will be secured around insulation to waterproof it. In new construction or major renovations, fiberglass bats will be nailed in place on walls and ceilings before drywall, paneling, or plaster walls are put in place. These fiberglass bats provide insulation that keeps the structure warm in the winter and cool in the summer. In finished buildings that did not have insulation when originally built, loose fill insulation can be blown in walls and attics. A helper feeds a machine with shredded fiberglass cellulose or rock wool insulation, while another worker blows the insulation from the compressor hose into the attic or between the interior and exterior walls.
You just got to get out and get some experience with it, work for somebody that's done it to learn how to do it. You got to make sure on the sidewalls all the cracks are stuffed and everything's sealed off. On-the-job experiences mostly, where you work for somebody that's already in it. Learn all the measurements, you know, how to read blueprints and everything. Of course, reading blueprints, if you go to school for that, that really helps.
Insulation workers should have a high school diploma, and classes in math, science, drafting, and blueprint reading will be helpful. Insulation workers can either learn on the job or through a 4-year apprenticeship program. Please remember that there is always some element of danger in any construction-related job. A moment of carelessness can mean a lifetime of tragedy. When on a construction site, follow directions from supervisors and stay alert. Income in the construction trades varies widely from one area to another, and it is impossible